Good morning, student. Today we are going to start Measures of Central Tendency, chapter number 3. In this, the index are given related. The content we are going to include, that is meaning, characteristics of good measure of central tendency, mean, its advantages, disadvantages, combined mean, weighted mean, geometric mean. Okay. Then positional averages, that is median, quartile, decile, and percentile. All of this advantages and disadvantages, and mode, its disadvantages and advantages, and graphical method. Means in this chapter we are going to study about mean, median, and mode. Okay, coming with the meaning, see here, the large volume of statistical data can be organized by classification and tabulation. This we have seen in our last chapter, that the data consisted with variable attributes. Okay, number of variables, having more than one variable they are having. They are being classified, arranged in particular proper way, and in tabulation, a table format. Okay, this shows certain characteristics of a given data. The diagrams and graphs drawn for the data show its trend and pattern. We have seen in the last chapter also that diagram is showing one kind of a pattern. A slope is coming downward, a slope is coming upward. By that we are able to understand that whether it is increasing or decreasing. It helps in visual interpretation and comparison of data. Interpretation, visual interpretation means we can see it and we can find out what is the particular situation going on. Comparison we can do with the current year or the past year. Okay, we need more concise and numerical representation. Concise means a small one, numerical presentation, a numeric presentation is being done of the data for further statistical analysis. Let us understand this with an illustration. They have given one example. Suppose a person is planning his monthly budget. The expense on every commodity is variable, which changes according to the quantity consumed and the market price. Okay, what it is telling, that every commodity is having a variable which changes according to the quantity. The quantity as which we are going to purchase is commodity, is intake is going to be change, and every time the market price is also going to change. Suppose he want to decide the amount to be spared for milk. Means spared means he want to invest the amount for the milk, or he want to store the amount for the milk. He has the value of milk expenses of past 10 months. He has kept a record of 10 months. He wants representative value from this data to provide for the expenses on milk in his budget. He has made a record of 10 months, that how much expenses he was bearing for the milk. So he had made a record. A representative value of more than one set of a data can be used for their comparison and further for taking future decision. We will illustrate this by the following situation. Now what they are telling, a particular value which we are keeping in record, that value is being utilized to compare with the current or with the past year. Okay, again they have given one example. Suppose a company wants to compare the sales of two products. A company is there who want to compare the sale of two products are there. They want to compare the selling price, or they want to compare the sale, how much it was done, produced by it. The sale vary from day to day. The sale was increasing or decreasing in each and every day. It was not similar, it used to vary. The company has data about sale of last 50 days. For last 50 days he has kept a data record, that what was the sale on each of the day. The pattern displayed by the sale of the two products can be compared from the frequency distribution obtained from this data. By this pattern, by keeping the record, he can compare that what was the sale on each and every day. Okay, by this two of the data. But the company needs some exact measure to describe the data of sale of their two products for further conclusion and comparison. Apart from that, he need a perfect mathematical solution which gives a conclusion, which gives us an answer, that what was the particular sale on each and every of the day. In most of the graph drawn for various frequency distribution, one can observe a common pattern, that the values of the variable are concentrated around a certain central value. Certain value means the numbers are moving near to one fixed value. Okay, we want to find that particular data. This characteristics of data is called as central tendency. a particular variable which is moving nearby one observation only, one value only, that particular data is known as central tendency. And the central value around which the value of the variable are concentrated, are moving, is called measure of central tendency or average value. Nearby that value, all other values are moving, then that is known as measures of central tendency, or the second name of that is given, that is average value. The average value thus can be taken as a representative for the whole set of a data. That particular central value we can assume for all the data in the ahead. We can analyze it also, we can interpret also, and we can make it for the comparison also. Thus, an average value first present the data in a concise form. It makes the data very small, shows the special characteristics of the data, highlight the important part, help in comparison between two or more set of data. The comparison between two variable can be done. Okay, these are the importance. Different measure of central tendency can be obtained for the collected data. For each and every data, we can find the central tendency, we can find the value. The choice of the average depend upon the type of a data, the purpose of a value, and its further application are given ahead. Coming to the next one, that is characteristics of a good measure of a central tendency. What are the characteristics? What are the importance? What are the main part or a personality we can tell about the particular observation which is moving near the one value? So first one, it should be well defined and rigid. It should be properly defined. It should be properly calculated, okay, and rigid. It should be in a good of nature. It should be easy to understand and calculate. We can understand it. It should not be very complex, and it should have an easy calculation. So you can underline the 2 point. First is defined and rigid. Second, we should understand and calculate very easily. Third, it should be based on all the observation of the data. Should include each and every observation of that particular data. Whatever data we have taken, each and every observation means all the numbers should be included in the part of a calculation. It should be suitable for further algebraic operation. All the particular data which are given, that should be properly used in an algebraic mathematical formation. It should be stable measure. Stable means one stable value should run up. It means the value of averages found for different sample of the same size from the same population should be almost the same. Means the particular average which we are going to find, different sample, for the different sample should have the same size. Okay, if we are taking any other sample, the sample should be having the same size, same population, then only we will get the answer perfectly. Means all the data of the observation should have the same characteristics. It should not be unduly affected by few very large or very small observation. The particular data which is there, okay, that should not be affected by very large data or very small observation. It should be very appropriate. So here are the 6 characteristics. Data should be defined and rigid. Data should be understandable and calculable. Data should have the calculation on each and every of the observation. Then the data should be suitable for the calculation part. The data should have a stable measures and all the observation should have the same property. Then it should not affect the data which are having small observation or very large observation. Okay. We will discuss the following measures of the central tendency which are widely used in the data analysis. In this chapter, we are going to study about mean, median and mode. In median, there are other positional averages and also they are known as positional averages. You can have a question that which are the positional averages or name the positional averages. So there are 4 positional averages: median, quartile, decile and percentile. Okay, positional means which particular averages are showing the position. पोजीशन से कौन आइडेंटिफाइड होता है? सो पोजीशन से आइडेंटिफाइड इज बीन डन, दैट इज मीडियन, क्वार्टाइल, decile and percentile. There are 4 positional averages. Okay, so we are going to study in this chapter mean, median, quartile, decile, percentile and mode. Clear here? Coming to the first one, that is mean, or the other name of the mean, that is given arithmetic mean. What is the other name of the mean? That is arithmetic mean. Meaning of this mean: arithmetic mean is defined as the value obtained by sum means total, of all the observation divided by total number of observation. Arithmetic mean: we are getting the mean by getting the total of all the observation. We are making the total of all the observation and dividing that total by the number of observation. The value which we are getting, that is known as arithmetic mean. The arithmetic mean of the variable x is denoted by x bar. How we are denoting mean? We are denoting the mean by x bar. Okay. Calculation of the mean. Now mean is divided into two parts. For raw data or ungrouped data, this is the first one, and second is for grouped data. Okay. Mean, median, quartile, decile, percentile and mode, they all are divided into two parts. One is ungrouped data, which is not been arranged, and second is grouped data. Okay. Again, this grouped data is divided into two parts, that is known as discrete data, and the second is continuous data. Okay, we have already studied in chapter number 2. Fine. Now here, these are the observation they have given. So the observation, total number of observation are denoted by n. Suppose they have given this observation, here they have given illustration 1. This all are known as observation x. Okay, and this is one kind of an ungrouped data, raw data, which is being known as. Okay, so this data is having total number of observation 8. Now what is the formula to find the mean? The formula to find the mean is sigma x upon n. I'll make you write the formulas also in our next slide, but today we are going with the theory. Okay, so this is the formula to find the mean, that is known as sigma. Sigma means total. Okay, total of all this observation, which is we are dividing by total number of observation, that is denoted by n. Means how many observation are there? So 1, 2, 3, 4, 5, 6, 7, 8. Total number of observation are 8. So they are denoted by 8. Okay, the value this which we are getting after dividing 61 by 8, 7.63, which we are getting, that is known as a mean, average mean. Okay, so this was about the mean. Coming to the next one, advantages and disadvantages of the mean, we will see. Yeah, page number 77, advantages and disadvantages of a mean. Mean is the most popular measure of central tendency because of its following advantage. First, we have seen I had only rigidly defined, very roughly defined. It has fixed mathematical formula. The formula has been fixed that we have to find mean by one of the formula, that is sigma x upon n for ungrouped data, and for grouped data the formula will be related with a plus sigma fd upon n into c. Okay, these are the formula. We will be studying the formulas also. So as the fixed formulas are being based, it is said to be very good one. Second, it is easy to understand and calculate. As we have seen the characteristics that we can easily calculate because the formula has been fixed, the pattern is fixed, the way of finding the answer, the steps are all fixed. We should not learn, we are not needed to learn the particular steps. They are all fixed. That's why it is very easy. Based on all of the observation, we are including each and every observation. Okay, it is suitable for further algebraic operation. We are having mathematical formulas over there. It is comparatively more stable, means whatever the point we have learned in the characteristics of a central tendency, the same points are included here as a part of advantages. So you can learn either there or you can learn this one. It means the means of all the sample of the same size from the same population have comparatively very less variation. The same point means each and every population and the size should be the same. Then all the observation are given equal importance in the calculation of the mean. Each and every observation number, they are having their own importance, they are having their own value. So the 6 points are as similar as the characteristics. Now what we have done here, that will be the opposite of the disadvantages. See here, it is unduly affected by too large or too small values. This point was there that it should not be affected by unduly small data or the large data, but it is being affected. So this is one of your limitation. Second, it cannot be calculated for the data having classes with open end. Open end means about less than 20 to 30 or more than 40 to 50. like this kind of a data if you are having, let me show you one example. You will be able to understand that which is known as open end data. So the open end, this kind of a data, just a second. In mean you are not having this one, but open end means I'll show you. Open end means this kind of a data when you are having, that is known as open end data. You cannot find mean in that particular classes. Okay, this kind of a data less than 2000 and 800 and above, open end classes, they are known as open end. Means no numerical value they are having, like this. As beginning we are having this one 0 to 100, then 100 to 200, 200 to 300, 300 to 400, like this. It are said to be simple. In this you can find the mean. But when you are having a data like this, they are known as open end classes. In this classes we cannot find mean over there, simply we have to find the positional averages. Okay, so in the open end classes we cannot find mean. Its exact value cannot be found graphically or by inspection. Roughly, if we are going with the help of a graph, we cannot find it. Or if we are coming for the survey or inspection we are doing, at that time also we cannot find the average mean. We have to compulsorily calculate the term. If few observations are missing, exact value of the mean cannot be found. There are total number of 8 observations, but from that 8 observation, any one is missing or 2 are missing, then the mean cannot be found out. Mean is not a good representative value for the data which are not evenly spread around their averages. Now what they are telling, mean, it is not said to be a proper particular term to find the particular observation or to find the averages when the numbers, when the objective, when the observation are being spread too large, too far. If the from the central tendency from any one number, the other numbers are separated or moving very far, at that time we cannot find mean. Okay, then using mean as an average is not an appropriate if observation having varying importance. Varying means different characteristics, different importance are given to each and every data, then this method we cannot use it. Okay, so here how to remember the point you can do. The first one, rigidly defined fixed mathematical formula, understand and calculate easily based on all observation, algebraic operations, then stable measures, comparatively less variation, and equal importance are given. You can remember this point and you can make as a by writing them. Only you have to remember the point and you can make the formation. Likewise, that only in disadvantages unduly affected by too large or small data, cannot be calculated with open end classes, graphical or by inspection cannot be used, exact value of mean cannot be found if observations are missing, not a good representative if evenly spread, then cannot be used if importance are varying. So these are the particular advantages and disadvantages which we have seen for the mean. Now coming to combined mean. Combined means we are combining two group and then we are finding the data. Okay, if we know the mean of two or more group of observation, we can find the mean of the combined group. Such a value is called combined mean. Means two group are given, group A and group B. We are combining all the observation. Group A is having their mean and group B is also having their mean. When we are combinedly joining them, when we want to join them and we want to find the combined mean that has been represented by C, then that data is known as combined mean. The formula is this, sigma C. It has been represented by sigma C equals to, this is group A when represented by 1, this is group B when represented by 2, and so on if they have given. So as basically the formula is sigma C, which is equals to n plus into x bar 1 plus n2 into mean 2 or x bar 2 divide by n1 plus n2. As many observations are given, you can proceed with that. Okay, so that is known as combined mean. When two groups mean are given, you want to find total of that mean, that is known as combined. Then they have given the example like this. Okay, now coming to weighted mean. Weighted means to find the weight of that particular data. Okay, we said that using arithmetic mean is not appropriate if the importance of all the observation is not same. Means all the observation they are having same importance, but the importance is not same. At that time, what we have to do? So a special mean, which is known as weighted mean, can be found in this cases. If each and every observation are given their importance, the values are given to them. At that time, if we cannot use combined mean or mean, then it is known as, we can find that is known as weighted mean. Weighted mean is denoted by x bar w. How we should denote it? X bar w. Each observation is assigned a numerical value called weight according to its importance. Means all the observation, suppose 3 is there, 3 will be having its importance, that is 4. Means each and every observation are being given their importance by any of the frequency or any of the number. Okay, then that particular part of working is known as what? Weighted mean. The most important value is given maximum weight. Whichever data is the having high importance, that is being given highest importance. So the formula of weighted mean is sigma w or x bar w. You can say w1 x bar 1, w2 x bar 2 plus so on as they are having. You are not going to add here mean. We are going to do with the observation. We are dealing with the observation, or we can do the formula as like sigma wx divided by sigma w. W is known as v. In two form we can write the formula, that is what? X bar w equals to w1 into x1 plus w2 into x2 plus so on they have given, divided by w1 plus w2 and so on. Or we can write in the second formation, that is sigma wx divide by sigma w. Here means what? W multiplied by x. So that is known as wx. Sigma means total. Okay, and divided by total weight. So two formulas we are having in weighted method. These are the two formulas. We can see the example they have given down. See here, a student get 35 mark in their theory paper, 15 mark in a practical examination, and 5 mark in the oral examination of the subject. The school gives weight, that is 4, 3, 2, 1. Means when he was having 35 mark, he got a weight of 4. When he was having 15 mark, he got a weight 2. And when he was having 5 mark, he got a weight of 1. So total weight is what? 4 plus 2, 6, 6 plus 1, 7. So total weight is 7. Then 35 multiplied by 4. See here, 35 multiplied by 4, 140. 15 multiplied by 2, 30. 1 multiplied by 5, so 5 means this part. Okay, so that is been divided. This 25 is said to be the weight mean mark of this student. Okay, so this was related with your exercise 2.2. Here we have done. Next, coming with the geometric mean. Geometric mean means we have to find the particular geometrical part or with the help of a root. Okay, here the meaning, geometric mean is defined as the nth root. Up till the number of observation, we are finding the root of the product of n positive observation. Product means multiplication of the observation which they have given, and it is denoted by capital G. It is denoted by what? Capital G. So G equals to nth root. See here, n is kept outside of the root, into observation multiplication. The multiplication of the observation, the product observation is being done by the nth root, that is known as geometric mean. So they have given the observation like this example. Two numbers they have given. This is x1 and this is x2. So 150 multiplied by root. How many observation they have given? 2 observation, but here we will be writing only 1. Nothing means 1. Okay, you have to decrease the part of that. So you will be finding the root 150 multiplied by 125, that is 136.93. Clear? Same way here, see they have given how many observations they have given. Here 2 is there, so we will be writing 2. Here 4 is there, so we have written 4. But in Calci we will be pressing the root only twice. Here we are writing 2 observations, so here we will be writing 2, but we will be pressing 1. That's why they have not mentioned here 2. Is that clear? 2 means pressing the root by 1 only, then only you will get the answer. Here total 4 we have written, so no need to press the root button in the calci 4 times. We will press it only 2 times. Suppose in a root we are writing 8, so no need to press the button of root 8 times. We will be pressing it by half 4. If it is written by 6, so we will be pressing it by 3. Means you have to take off the particular term half, then you are able to find the geometric mean. So geometric mean is what? Product of the observation with its nth root is known as geometric mean, and it is been denoted by G. Is that clear? Now advantages and disadvantages of geometric mean. Rigidly defined with each and every criteria based on all the observation, suitable with algebraic calculation, comparatively less affected by too or large or too small values. Same as like the characteristics what we have seen, because this is a part of a mean. So advantages you will be having similar only. Okay, so same point you can underline. Disadvantages, it can found only if all the observation have positive value. Negative terms are not welcome. We can only welcome positive terms. It is difficult to calculate. Why it is difficult? Because the observation which we are dividing 6, then we have to press it 3 times, 4 8, then we have to press it 4 times, 4, then we have to press it 2 times. So somewhat the calculation the student used to forgot that at what time we have to press it, the root. Its calculation becomes difficult if the number of observation is very large. We can do it for only small data. We cannot use it in very large data. Is that clear? So you can underline, should have the positive value for remembering the points. Difficult to calculate, and if observation is very large, we cannot calculate it. So this was about the mean. Now coming to positional averages. Positional averages is divided into 4 parts: median, quartiles, deciles and percentile. Write the name, 1 mark question. Write the name of the positional averages. So that is median, quartile, decile and percentile. Is that clear? Because they are found on their positions. Position specified kiya jata hai. That's why it is known as positional averages. Coming with the first, what is a median? Median means finding the middle value. Finding the middle observation value. Median is defined as the value of the middlemost observation when the data are arranged in ascending or descending order. Now, when the data has been either ascending or descending, you have to arrange them first. Then after finding the middle value, the particular number is said to be a median. It is denoted by capital M. In other words, 50% value of the observation in R, the above median, and 50% of the observation have value less than the median. Means 50% data are included in the median value and 50% of the observation are having the value less than the median. Now the formulas are also given as per ungrouped and grouped data. We will again go with the formula. Clear? So just we are going, when ungrouped data is there, remember one thing, ungrouped data means not arranged. Okay, in that particular data, median value will be n plus 1 divided by 2, plus 1 will come. Okay, this data is ungrouped data. Okay, this data is said to be what? Ungrouped data. They are not being arranged, so plus 1 will come. Then this is the grouped data. Grouped data for the discrete frequency. When discrete is given, in discrete also plus 1 will come. But when the data is related with the classes, like this classes, at that time the formula for median will change. There only n by 2 will come. Remember that. Where n plus 1 divided by 2, median means dividing into 2 parts. So in median it will come 2. So here when n plus 1 will come, when only ungrouped data and discrete data is there you have to write n plus 1. But when continuous is there, continuous, at that time n by 2 only you have to take. Okay, again one more thing, median is divided into 2 parts, quartile is divided into 4 parts, decile is divided into 10 parts, and percentile is divided into 100 parts. So in denominator, the value which we are taking in the formula 2, okay, that is going to vary when we are solving the term. If percentile, then 100, quartile, then 4, median, then 2, and decile, then D. No, 10. Okay, so this was related with the discrete, this was related with the continuous. Now this was about the part of median. Now going with the advantages and disadvantages of the median. Let's see the advantage. First advantage of median, it is easy to calculate and to understand. Very simple it is, only we have to input the formula as per ungrouped and grouped, and then we have to calculate the term. So it is said to be one part of very easy calculation and we are able to understand. So underline a point, calculate easily and understand it easily. Then the next, it can be found out by inspection. How by inspection means, suppose my number of data is 61 or 50. Okay, among that 50, median if I want to find, so 50 divided by 1, 50 divided by 2, median is divided into two parts, so 50 divided by 2 if it is continuous. If it is discrete or ungrouped, then 50 plus 1 divided by 2. So by oral also I can find out what is the value of the median. So by inspection or oral calculation we are able to easily find out. Same way by graph also we are able to find out that what will be the median. Fourth, it is only available average when the frequency distribution has open-ended classes. When we can find the particular median, when the open-ended classes are coming. It is less affected by too large or too small data. It is not at all affected by if the data is very big or if the data is very small. Median is not being at all affected. It can be calculated even if certain data are missing. Like in frequency, what was there, that the particular term cannot be found out if any one observation is missing in me. But in particular median, it is not like that. You can find out any of the particular median, quartile or decile if any one observation is missing. So here, if the data are missing, then also we can easily find out the median. Okay, this was the advantages, somewhat related with the characteristics of good measures of central tendency. Now let's see the disadvantages. Not rigidly, not properly arranged, not based on all the values, each and every value is not being taken, not suitable for mathematical formula, a perfect formula is not coming over there. Then less stable measures of central tendency are compared to mean, means comparatively mean the particular tendency is very less. Okay, so this was the advantages and disadvantages. Now quartile, other positional averages. Quartile, which is divided into four parts. Okay, see here also, when the observation of the given data are arranged in ascending order, we have to first arrange them. Three values which of the data is divided into four equal parts are called quartile. We are considering only three here. In quartile, we are considering Q1, Q2 and Q3. So three data which is equally divided into four parts, that is known as quartile. Okay, so here when the observation of the three data is divided into four parts, that is known as a quartile. Here Q1 is known as 25% and the value will also be Q equal to Q1. Then Q2 will be the next 25%, that is known as 50%. Q3 will be the next 25%, that is known as 75%. And apart from that, Q4 we are not calculating in this particular chapter because it is not included. So we are only going to solve three terms, that is Q1, Q2 and Q3 only. Okay, so basically it is known as that Q1 is equals to 25, then Q2 is equals to 50 and Q3 is equals to 75%. Okay, this is the term you have to remember. After that, decile means arrange in ascending order, and the 9 values from 1 to 9, the 9 values are divided by 10 equal parts, that is known as a decile. From 1 to 10, the 9 observations are divided into 10 parts, that is known as a decile. Here also this is one most important term you have to remember, that the value of d5 will always be equal to m and m is always equal to q2. Because 5 means half, median means half and 2 means half, means they are same in term. Percentile also means arrange in ascending order. From 1 to 99 values, it has been divided by 100 equal parts, that is known as percentile. In percentile also, D1 is equals to known as P10, D2 is equals to known as P20, likewise so on. D9 is known as P90 and D10 is known as P100. Okay, Same way, Q1 is known as P25, Q3 is known as P75, and M, which is equals to Q2, D5 and P50. These are important. You have to remember these things because they will be coming in the part of an MCQ, or in a short sum the value of one observation will be given and you have to consider it as a value of the other observation. So this are said to be one of the important point. Okay, so this we have done about quartile, decile and percentile. Next we are coming to the mode, which is the last part of this theory. Okay, after that we will be having the video related to the formulas, or I'll be sending the pics related to the formulas to you. Now what is mode? You have already learned in the last year that mode means what? Repeated number of a frequency, repeated number of the observation, maximum time. Okay, so that is known as mode, or the highest frequency observation will be considered as mode. So see here, the value which gets repeated maximum number of time, or the value occurring with maximum frequency in the given data is called mode. Repeated number, for example in this sum, which number is repeated many times? 7. Okay, 2 times, then 1, 2, 3. 6 has been repeated 3 times, so maximum 6 has been repeated 3 times, so 6 is said to be what? Mode. Same way in this question here, in this discrete, this table is known as discrete table, where observation and frequency are given, they are known as discrete. Where continuous classes and frequency is given, that they are known as continuous classes observation. When only observation are given, they are known as ungrouped data. Okay, so remember this thing. So here what is the highest frequency? Frequency will be your next part. Here highest frequency is 22. So 22 is not your mode, but in front of 22 the observation which is given, that is what? 19. 19 is said to be your mode. So mode is what? The maximum value which has been repeated number of times, or maximum frequency or observation is said to be a mode. And mode is defined by MO. Mode is defined by MO. So this is about the mode. Okay, this part is said to be the mode. Now after that, advantages and disadvantages of mode for the last. Also you will be having one more thing, that is known as empirical formula. Empirical formula means you will be using this formula to find mode where there is unequal class length. Unequal class length means the classes difference, CL is coming very different in each and every data. In few of the classes it is 5, in after that next classes are 10, after that next classes are 20, means where the class length is very different. There we have to use this empirical formula, that is known as mode equals to 3 median minus 2 mean. There we will be using this particular formula. Okay, now in this what they have given, this formula for mode is used in the following situation. Each observation appeared just once in a raw data, only one time if the observations are there, no repeated numbers are given. At that time we have to use this. More than one observation in a frequency distribution appear with the highest frequency, means appear with the one observation in a frequency distribution having highest frequency maximum time. At that time we can use. Then continuous distribution has class of unequal class length. Unequal class length is given at that time when data are given at once only. Then distribution appear with highest frequency, there we can use this, as I have given that example, that the frequency distribution is mixed distribution, that is discrete and continuous both. Discrete and continuous means you will be having the data like this. This is known as discrete and this is known as continuous. When this type of a data is given, there we will be using this empirical formula. Okay, so and the next point after that, the right or left end of the curve of the frequency distribution is too extended. Right part or left part of the curve like this. Okay, a curve is there. So here the left part or the right part is extended too much, this part. Then at that time also we have to use the empirical formula. Okay, is that clear? Now after that they have given graphical method. With the help of graph also we can find the particular mean, median. Okay, so particular mean, median, quartile, when we are finding with the help of a graph, they are known as a graphical method. Fine, and basically it is being used with the data which is having equal class length. We cannot use graphical method in unequal class length. Now coming to the advantages of mode, it is easy to understand and calculate, same as like the characteristics. Then inspection, by inspection also we can able to find the mode. It is not affected by too large or too small values. If the data is large or small, it has not been affected at all. Then this can be helped with the help of a graph also. We can find the particular mean, median, mode by the help of graph also. Then same like the median, it is not rigidly defined, not equally or properly arranged. There can be more than one mode for the given variable, whereas sometimes the mode cannot be found. It happened that more than one mode is given. Two modes are having, highest frequency will be given like that, or at times you won't be having mode also. At that time we have to use what? Empirical formula to find the mode. Third, it is not based on all the observations. Same like mode, each and every observation is not being taken into calculation. It has less stability in sampling as compared to mean. As compared to mean, median, the stability is very less. It is not suitable for further mathematical calculation. The proper calculation, the terms are not being considered in this particular part. Okay, so this was the particular mode, advantages and disadvantages. So here we are having the last point, comparative study of mean, median and mode. In this, comparative means comparatively which one is said to be very good. So see here, among all the averages, mean satisfy most of the requisite of the good average, and hence it is used in most situation of data analysis. Means mostly everywhere mean is being used. The most important property of mean is its compatibility. Comparison can be done for further algebraic computation. With other mathematical calculation, we can use this one. The advanced statistical method applied for studying various characteristics of a population or for comparing two populations used mean as a representative value for the variable under consideration. This point make mean an optimum measures of central tendency. Optimum means best. Among mean, median and mode, which one is the best for central tendency? So mean is said to be a best. This is your one more question also. Okay, however, mean cannot truly represent the entire set of data when the data are not evenly distributed, not equally distributed. Many variables studied in agriculture, social science and in business activity are not found to be evenly distributed. Equally, they are not being distributed. At that time, we cannot use the method of mean. Median is better measure of central tendency in this situation. When it is not evenly distributed, what is comparatively to be used? Median. Okay. Median is used as an average in qualitative data like education, skill and consumer satisfaction. Means median is being used in quantity also and quality also. Now coming to mode. What is about mean? Mean is said to be the best one, but when the data is not equally divided, at that time we have to use median. Now about mode. Mode is particularly used in the business and commerce field. For qualitative data also, mode is found to be useful and average while deciding the dishes served at a restaurant and their flavor. The choice and the taste of maximum customer is taken into consideration, which is an example of a mode, which we maximum number who like this taste, maximum person who like this particular dish. So at that time we can evenly decide that what will be the frequency, what will be the average. So at that time what we are deciding that who likes the most, that part is known as mode average. Okay. Mode is extensively used for finding the average by ready-made garment manufactured and in footwear industry. Where it is being used in footwear and ready-made garments, the people are using it more. So each and every particular average is having their own tendency in the market. So this was about the theory of chapter number 3, measures of central tendency. Soon I will be sending you the particular formulas of this particular chapter by PIC. Thank you.